Alright, so we know about sine and cos, but where in the world does tan come from? Well, let's check out a little bit of a video on how to find tan.
So let's now have a look at the unit circle in a little bit more detail, shall we? So I'll just draw it out quickly, and as you can see here I've drawn a line, so I'm going to find out what cos of 60 is and what sine of 60 is. So of course cos of 60 is equal to 0.5 and sine of 60 was equal to 0.866. Now if we have a look at this, we've actually got this point here as being at the coordinates 0.5, 0.866, because this coordinate here, well, I'm 0.5 across and I'm 0.866 up. Now if we have a look at this line, well, it's kind of like a linear graph, isn't it? Because it's just a straight line. Now of course, if I want to find out anything about the linear graph, such as the gradient, I can use rise over run. That is, I've gone up 0.866 over a run of 0.5. So therefore, my gradient will be equal to 1.73. So I can actually find out the gradient of this line. Now there's actually another way to find out the gradient of this line, and that is to use 2 points. So that is y2 minus y1 over x2 minus x1. Now hopefully this is all coming back to you. So for y2 minus y1 over x2 minus x1, well, we need 2 points. And of course the first point, once again, is at 0.5 because it's 0.5 across, and 0.866 because it's 0.866 up. And the second point, well, of course, we can get that from here, can't we? Because it's at 0, 0. So let's go through and substitute those values in. Now, y2 minus y1 will be the same as saying 0.866 minus 0. There we go. Now, the x2 minus x1, well, it's going to be 0.5 minus 0. So it's 0.866 minus 0 over 0.5 minus 0. And of course that will get us 0.866 divided by 0.5, which was the same as what we had before, which of course is equal to 1.73. Now, that should be the case because this hasn't changed at all, so of course the gradient is going to remain the same. So if we have a look, there are actually 3 formulas back from the very beginning of the year that we can use for gradient. So as you've just seen, rise over run, y2 minus y1 over x2 minus x1. But then there's a third method that people always forget about. And I don't know why, but I've done it too. But there's a third method that people always forget about. And that's what we're going to go into now. So to find the gradient, we're going to look at this new method. So I'll draw it all out again. Alright, and to find the gradient, you actually can use tan theta. So what we're going to do now is you're going to go through and you're actually going to put in tan of 60 into your calculator. So when you've done that, press pause, and hopefully what you'll find is that your answer is equal to 1.73. So like I said, press pause now, go through and do it, and see that you get an answer of 1.73. Now of course, this answer here will be the same as every other answer that you've gone through and got to find the gradient from before. So do that now. Excellent. So hopefully what you've just found is when you've gone through and put tan of 60 into your CAS calculator, you've got an answer of 1.73. Now if you didn't get an answer of 1.73, you need to make sure that you check your settings to ensure that your CAS calculator is actually in degrees mode, not radians or grad, right? Because they're going to give you different answers. So it needs to be in degrees mode. So as you can see, tan 60 is equal to 1.73. So let's now look at the tangent and how we can get the tangent from sine and cos. Now because we know that we can get the gradient by using tan theta, that is tan theta is equal to the gradient, we know that we can also use tan theta is equal to rise over run, because the gradient is the same as saying rise over run. Now because I know that is the rise over the run, I can also say that the gradient is equal to y over x. Now, what was y the same as? Well, y was the same as sine. And what was x the same as? Well, x was the same as cos. So therefore, tan theta is equal to sine theta over cos theta, such as what you can see here. And that's really important because that can actually help us to find what tan theta is when we know what sine and cos are. So, in other words, if I want to find out tan of 60, I can find out sine of 60 and cos of 60, I can actually use these values. So that is for tan of 60, I can use the sine of 60 value of 0.866 from this unit circle. I can also use the cos value of 0.5 from the unit circle, and I can essentially just write tan of 60 is equal to 0.866 divided by 0.5, which of course will give me the answer of 1.73, as we've seen. Now there's a little bit of a diagram that we can use in order to represent tan, and that is what I call the tan line. No, not that kind of tan line. This tan line that you can see here, the one that's going straight up and down at the cos value or the x value of 1. So that is a tan line, starts at 1 and continues up. Now it's really important that we understand that it starts at 1 because this is how it works. That is, if we start at this line at the origin here and we draw the line up to the unit circle, we then continue on in the same direction and we want to find out how high up it'll hit the tan line when x is equal to 1. Now, if we have a think about this for a second, of course, I've got my line here at 0.5, or an x value of 0.5, it's got a y value of 0.866. Now, if we think about the relevance of the x value of 0.5, of course, it's halfway to 1, isn't it? So if it's halfway to 1, therefore, the height must double. That is, we're going to get the same line pretty much here, and just move it up to here. So it's going to be twice the height. So let's actually watch that happen. Oh, there we go. It's just happened. So as you can see here, my height will be at 1.73, or my tan value will be 1.73 because it's essentially just double. Alright, if I had my x value being 1/3, for example, of course it's going to be 3 times the height because it's going to have to go up 3 times higher. And if I have it right here, well then this line is going to continue up really, really high on the tan line. Whereas if I have it down here, so a low angle or a small angle, well then it's not going to reach up too high on the tan line. So that's how we can actually figure out tan. Now remember, of course, tan theta is equal to sine theta divided by cos theta. So there are 3 ways for finding the gradient of a straight line. Remembering back to the beginning of the year, that is rise over run, y2 minus y1 over x2 minus x1, and of course, tan theta. Now don't you forget it. Alright, so let's now have a look at which regions will give positive results for different sine, cos and tan values. Now if I have a look here, if I was to draw a line from here to here, what values would be positive? Well, I'd have my cos theta would be positive because you can see a positive value here. My sine theta would be positive because I'd have a positive value here. And of course, sine divided by cos, or positive divided by positive, will get us a positive for tan. Therefore, all of them are positive. Whereas when we come over here, if I drew a line out here, of course, my cos value would be negative, my sine value would be positive, and when I go a positive divided by a negative, I get a negative for tan. So therefore, only sine will be positive. Now when I come down here and draw a line, of course, my cos value will be negative, my sine value will be negative, and when I do a negative divided by a negative, I get a positive value for tan, so therefore only tan will be positive in this one. And if I draw a line coming out here, well, my cos value will be positive, my sine value will be negative, and of course when I do a negative divided by a positive, I'll get a negative for tan, so therefore only cosine is positive. So therefore, another way to remember this really is all stations to Croydon. That is, all of them are positive, sine is positive, tan's the only one that's positive, and cosine is the only one that's positive in the 4th quadrant. Alright, so let's go through and just summarise everything that we've learnt through looking at the unit circle. Now if we have a look, of course, all of them are positive in the 1st quadrant, only sine's positive in the 2nd, only tan's positive in the 3rd, and only cosine is positive in the 4th. My y-axis is represented by sine, my x-axis is represented by cosine, and my tan theta, well, I can actually find that by doing sine theta divided by cos theta. So there you have it, guys. There's the unit circle pretty much summarised. Make sure you go through and attempt some questions related to it. And of course, if you do get stuck, make sure you ask your teacher.
Cool, so I guess you've just seen how sine, cos and tan have come about. Now let's go through and have a look at some worked examples on how to actually work with these.
So we're going to have a look at a couple of worked examples now for the unit circle. And the first one says determine whether the following will be positive or negative. That is sine of 140, cos of 260, tan of 200, and cos of 540 degrees. Now the very first thing I recommend you always do when working with the unit circle is actually to draw it out for each question. So let's go through and answer sine of 140 degrees. So let's draw out the unit circle like so. So just your axis here and here, and like you can see here and here. Now of course this is sine theta, and this of course is cos theta. Now let's go through and actually label the degrees. So we've got 0 degrees here, 90 degrees here, 180 degrees here, and 270 degrees here, like so. And we'll go through and we'll draw out our unit circle, where of course the values here are 1, 1, -1, and -1. Now let's go through and actually plot our line, that is where our angle will be. So it says sine of 140 degrees. So I start off at 0 and I go around to 90. Now 140 is more than 90 but less than 180. So therefore 140 degrees is going to be roughly here, like so. And that there is going to be 140 degrees. So it says sine of 140, and if I have a think about it, I know that all stations to Croydon, I know that sine will be positive in the second quadrant. And because it says sine of 140, I know that sine of 140, because it's in the second quadrant, will be positive. Right, the next question says cos of 260 degrees. So let's go through once again and actually draw out the unit circle. Now it doesn't need to be perfect, as you can see there. And I've got all stations to Croydon like so. Now it says cos of 260 degrees. So where's 260 degrees going to be? Well, I know it's going to be more than 180 but less than 270. So it means it's going to be in this quadrant here. That is from there around to there. Now because it's in this quadrant here, it says tan's positive and we're talking about cos. So only tan's positive in this one. So therefore cos of 260 degrees will be negative, because only tan's positive in that quadrant. So now what I want you to do is actually press pause and attempt the last two questions. That is tan of 200 degrees and cos of 540. Remember, when you're done to press play so you can check your answers out against mine. Excellent, so welcome back. Now as you can see here, I've gone through and drawn out my unit circle for each of the questions, and let's go through now and plot whereabouts the line of 200 degrees will be. Now if I have a look over here, 200 is going to be more than 180 but less than 270, so it's going to be in the third quadrant. And because it says tan of 200 degrees, well, I know that tan is positive in this quadrant and only tan is positive, so therefore tan of 200 degrees is positive. That is, it'll give me a positive answer. Now for cos of 540 degrees, well, let's go through and plot where 540 degrees will be. And this is a little bit harder because it's actually the same as saying cos of 360 plus 180, because that's what 540 is equal to. So it's kind of like going through and actually getting this line here and going, well, I'm going once around to 360 and then I go another 180 around to get to 540. And that's going to get me all the way around to this value here. Now, is it in any quadrant? Well, it's not exactly, but if we have a think about it, we remember that cos is along the x-axis, and of course the x is going to be negative here. So because of that, I know that cos of 540, that is what you can see here, cos of 540 is equal to a negative answer. And we actually know that that's going to be -1 in this case. Excellent, so now what we're going to do is have a look at the next question, where it says determine which quadrant A, that is A degrees, is in if sine A is greater than 0 and cos A is less than 0. So in other words, sine A needs to be a positive answer because it's more than 0. So sine A, we're looking for where sine A is positive, but cos A is going to give us a negative answer. So therefore, where cos A is going to give us a negative answer. So let's go through and draw our unit circle out once again, like so. We're going to just go here like that, just do it real quick, a circle around here like so, and let's just go through and write all stations to Croydon. But then what I'm doing is looking for a quadrant where sine is positive and cos is negative. Well, all of them are positive here, so therefore it counts out the cos being negative, so it can't be in the first quadrant. In the second quadrant, sine is positive and cos is negative, so it means it could be there. In the third quadrant, well, tan's positive, so that's got nothing to do with it, but sine and cos are both negative, so therefore it can't be in the third. In the fourth quadrant, only cos is positive, so therefore it can't be in there because we're looking for where cos is negative. So therefore the answer is in the second quadrant. Now what I want you to do is actually press pause and attempt the last two questions. That is, find which quadrant that A would be in if tan A is less than 0 and sine A is less than 0, and then for C, where cos A is greater than 0 and tan A is greater than 0. Right, so like I said, press pause, attempt the questions, and when you're done, press play so you can check your answers out against mine. Excellent, so welcome back. Now as you can see here, I've gone through, drawn out my unit circles for each question, and I've gone through and read the question where it says tan A is less than 0, so that means tan A needs to be negative. And sin A is less than 0 as well, so therefore sin A needs to also be negative. Now in what quadrant are both sin and tan negative? Well, it's not going to be the first because they're both positive. In the second, sin's positive, so it can't be that. In the third, tan's positive, so it can't be that. So therefore, it means that it must be in the fourth quadrant where only cosine's positive and tan and sin are both negative. So therefore, the answer is the fourth quadrant. In question C, we're looking for where cos A is greater than 0, therefore cos A must be positive. Tan A is greater than 0 as well, so therefore tan A must be positive. Now if we have a think about that, both cos and tan are positive in the first quadrant, whereas over here they'll be negative, both of them will be negative. And over here in tan, well, cosine's going to be negative, and we're looking for where it's going to be positive, and over here tan's going to be negative, so it can't be in the fourth one either, so therefore it must be in the first quadrant.